All right, so this one is a great question. It's saying each of the figures below shows the path of a charged particle moving in the plane of the page in a magnetic field that is perpendicular to the page. If the mass, speed, and charge of the particles are the same, in which case does the field have the greatest magnitude? So we're saying, okay, M, V, and Q are the same, and then we want to look at B. So what we're really looking at here is objects curving different amounts. So if we're thinking about what variable that is, we can kind of call it r, the radius of this curvature. So we saw on Friday that when we have a magnetic field introduced to a charged object, it causes it to curve. We saw that one real life example where I had that laser and it was like this. When we brought the magnet near it, then that thing began to curve. That charged line of charge began to curve. And we also saw the video of the TV, the cathode ray tube TV, where the beam of particles were curving. And we said that this happens because the velocity is perpendicular to the force. When we've been dealing with that case before, with velocity perpendicular to force, we said that we get a curving. We get this circular motion. So we're looking at really a case of circular motion. So we know that a centripetal force, any force can be a centripetal force. In this case, our magnetic force is acting as our centripetal force. So we can use this equation, mv squared over r equals our force, qvb. So I can move a few things around. I can cancel out one of these v's and say mv over r times q equals b. And now I can really look and see, hey, if I want this b to be really big, this r, the only thing that we can compare, because we said m, v, and q are the same, is r has to be small. We have to have a small radius of curvature. So we compare these. This looks like something for a really big circle with a really big radius. This is a less big radius, a smaller radius, and this one has a very small radius. So we know that D has the smallest r, which means that it is going to have the smallest magnetic field. The largest magnetic field. Whew, almost messed it up right at the end. All right.